Okay, in the start of this next unit, we're going to start out with the properties of acids and bases. So what is an acid? An acid is a group of chemicals that I would say that exhibit many different or many similar properties. They will usually have a, not usually, they will have a pH that is less than 7, a pH under 7. And this has to do with this H here thing. I'm not going to use the word always, but these acids are going to have these H plus ions in solution. So they're going to have these H plus ions in solution. Acids are going to tend to taste sour because these H plus ions are hitting receptors on our tongue, which tell our brain this group of feelings, which we then use the word sour to talk about. Acids are going to turn litmus paper. Now in the lab, I kept saying blue pH paper. It's really litmus paper. So they're going to turn litmus paper red always. So they would keep red litmus paper red, but they would turn blue litmus paper red. They tend to react with metals. So acids tend to react with metals. Now coming over here to our picture, maybe I could maybe say that the acid HX, X is just random, reacts with like an element, I don't know, let's say magnesium, to produce this MgX plus H2 gas. So they tend to produce this hydrogen gas. Okay, acids also tend to react with carbonates. Now this might be calcium carbonate, magnesium carbonate, or even something like sodium bicarbonate. So even if it's a bicarbonate, you're going to see this type of reaction. So if we came back over here, so if we have HX again, reacting with, like, let's just say BCO3. So what's going to tend to happen here is we get an H2O. So we have this H going with some of these oxygens. We get CO2 gas usually from these carbonates coming out. And that's coming from this carbon and some of these oxygens. And then we get this positive ion going with this negative ion, so plus BX. And then once you get this set up, then we usually have to balance this. So, we have this cation reacting with this anion, a carbon dioxide getting kicked off here, and then some of these oxygens going with some of these hydrogens to produce that water. So it is a different gas here. So we see that carbonates do react with acids, which is maybe important because when we have things like marble or certain construction materials made out of carbonates, we know that acid rain is maybe dissolving those down a little bit. Okay, so I think, acids can also be corrosive, which means they can, if they are strong enough, they can dissolve things away. And acids would oftentimes start with an H at the beginning of the formula. Okay, now what about bases? So bases will have a pH that is above 7, so they have a high pH. Bases tend to have this OH minus in water. So they'll tend to produce these hydroxide ions in water. Bases are going to taste bitter. Now I would not use in our lab a taste test as the way to find out if something's acidic, like you find an unknown bottle, like, oh, let me just taste it and see if it, because remember they can also be corrosive. So some kind of weird things going on at times. So coffee, if you were to test it with pH paper, you'd see its pH is probably under 7. Overall it's acidic, but the reason why coffee tastes bitter is because the caffeine chemical in there is basic, and it gives you this bitter taste. Again, bitter is just our brain sensation of these OH minus ions hitting your tongue. So the bases would turn litmus paper blue overall. So I always remember that. So basic blue, and then acid ends with D and red ends with D. Bases are not going to react with metals so much. They're not going to react with carbonates, but they are still corrosive. So when people feel a base, sometimes they feel they feel slippery, and you're like, whoa, this feels slippery. What is that? And you know, that's that base dissolving away your skin cells, really. So that slippery feeling when you touch like maybe some Drano, which you shouldn't be touching, or maybe like an ammonia type product, that slippery feeling is those cells kind of dissolving away. Okay, let's just go down and practice some of these concepts here. So describe what these would be. Red litmus paper blue, that's a base. A pH above 7 would be a base. Reacts with metals is an acid. The term neutral would mean pH 7, so that would be neither, I guess. Corrosive would be both. Tastes sour is acid. A high concentration of H plus would be an acid. Now this is not how I described it, but if a lot of H plus means an acid, if you have a low concentration of H plus, and we'll learn how to kind of quantify this later, I would say that would be then a base. HCl, the trends we saw that acids tend to start with an H at the beginning of the formula, so that would be an acid. OH at the end of a formula tends to be a base. And then NaCl, we're going to learn about this more later, but I would say that's probably, neither. And we'll learn more about salts later. Okay, on the right, I'd like you to try these, and then I would like you to look up on your own just which acids are strong and which bases are strong. And we're going to try and memorize these acids and memorize these bases. And if we memorize the strong ones, there's about 7 each. Everything else would be a weak acid or weak base. So that's going to be part of your homework here. Okay, I hope that was a good start for us, and we will continue learning about acids and bases next class.